Hello guys, I will introduce you about the C language, and in this video, I will give you an explanation about the C language introduction. But before I explain this topic, please like, subscribe, comment, and share so that I will be more enthusiastic in making other interesting videos. You can see that there are some learning topics about this. They are definition of the C language, history of the C language, characteristics of the C language, features are not available in the C language, reference manual of the C language, benefits of making reference manuals, excesses of the C language, deficiencies of the C language, prospects in studying the C language, offline compiler for the C language, online compiler for the C language, code editor for the C language. For the first learning is definition of the C language. C is a general-purpose programming language. It has been closely associated with the Unix system where it was developed, since both the system and most of the programs that run on it are written in C. The language, however, is not tied to any one operating system or machine, and although it has been called a system programming language, because it is useful for writing compilers and operating systems. It has been used equally well to write major programs in many different domains. Many of the important ideas of C stem from the language BCPL, or Basic Combined Programming Language, by Martin Richards in 1967. The influence of BCPL on C proceeded indirectly through the language B, which was written by Ken Thompson in 1970 for the first Unix system on the DEC PDP-7. But the C language itself is written by Dennis Ritchie in 1972. BCPL and B are typeless languages. By contrast, C provides a variety of data types. The fundamental types are characters and integers and floating point numbers of several sizes. In addition, there is a hierarchy of derived data types created with pointers, arrays, structures, and union. Expressions are formed from operators and operands. Any expression, including an assignment or a function call, can be a statement. Pointers provide for machine-independent address arithmetic. C provides the fundamental control flow construction required for well-structured programs, such as statement grouping, decision-making or if-else, selecting one of a set of possible cases, or switch, looping with determination test at the top, or while and for, or at the bottom, or do, and early loop exit or break. Functions may return value of basic types, structures, unions, or pointers. Any function may be called recursively. Local variables are typically automatic or created anew with each invocation. Function definitions may not be nested, but variables may be declared in a block structure fashion. The functions of a C program may exist in separate source files that are compiled separately. Variables may be internal to function, external but known only within a single source file, or visible to the entire program. A pre-processing step performs macro substitution on program text, inclusion of other source files, and conditional compilation. C is a relatively low-level language. This characterization is not pejorative. It simply means that C deals with the same sort of objects that most computers do, namely characters, numbers, and addresses. This may be combined and moved about with the arithmetic and logical operators implemented by real machines. C provides no operation to deal directly with composite objects such as character strings, sets, lists, or arrays. There are no operations that manipulate an entire array or string, although structures may be copied as a unit. The language does not define any storage allocation facility other than static definition and the stack discipline provided by the local variables or functions. There is no heap or jailbreak collection. Finally, C itself provides no input or output facilities. There are no read or write statements and no built-in file access methods. All of these higher-level mechanisms must be provided by explicitly called function. Most C implementations have included a reasonably standard collection of such functions. Similarly, C offers only straightforward single-thread control flow, test, loops, grouping, and subprograms, but not multiprogramming, parallel operations, synchronization, or coroutines. Although the absence of some of these features may seem like a grave deficiency, keeping the language down to medium size has real benefits. Since C is relatively small, it can be described in a small space and learns quickly. A programmer can reasonably expect to know and understand and indeed regularly use the entire language. For many years, the definition of C was the reference manual in the first edition of the C programming language. It is a book. In 1983, the American National Standards Institute, or ANSI, established a committee to provide a modern, comprehensive definition of C. The resulting definition, the ANSI standard, or ANSI C, was completed late in 1988. Most of the features of the standard are already supported by modern compilers. The standard is based on the original reference manual. The language is relatively little changed. One of the goals of the standard was to make sure that most existing programs would remain valid, or failing that compilers could produce warnings of new behavior. For most programmers, the most important change is a new syntax for declaring and defining functions. A function declaration can now include a description of the arguments of the function. The definition syntax changes to match. This extra information makes it much easier for compilers to detect errors caused by mismatched arguments. In our experience, it is a very useful addition to the language. There are other small-scale language changes. Structure assignment and enumeration, which had been widely available, are not officially part of the language. Floating point computations may now be done in single precision. The properties of arithmetic, especially for unsigned types, are clarified. The preprocessor is more elaborate. Most of these changes will have only minor effects on most programmers. A second significant contribution of the standard is the definition of a library to accompany C. It specifies functions for accessing the operating systems or for instance to read and write files, formatted input and output, memory allocation, string manipulation, and the like. A collection of standard headers provides uniform access to declaration of functions and data types. Programs that use this library to interact with a host system are assured of compatible behavior. Most of the library is closely modeled on the standard I/O library of the Unix system. This library was described in the first edition and has been widely used on other systems as well. Again, most programmers will not see much changes. Because the data types and control structures provided by C are supported directly by most computers, the runtime library required to implement self-contained program is tiny. The standard library functions are only called explicitly, so they can be avoided by they are not needed. Most can be written in C, and except for the operating system details they conceal, are themselves portable. Although C matches the capabilities of many computers. It is independent of any particular machine architecture. With a little care, it is easy to write portable programs, that is, programs that can be run without change on a variety of hardware. The standard makes portability ISOs explicit and prescribes a set of constants that characterize the machine on which the program is run. C is not a strongly typed language, but as it has evolved, its type checking has been strengthened. The original definition of C from on, but permitted, the interchange of pointers and integers. This has long since been eliminated, and the standard now requires the proper declarations and explicit conversions that had already been enforced by good compilers. The new function declarations are another step in this direction. Compilers will warn of most type errors, and there is no automatic conversion of incompatible data type. Nevertheless, C retains the basic philosophy that programmers know what they are doing. It only requires that they state their intentions explicitly. C, like any other language, has its blemishes. Some of the operators have the wrong precedence. Some parts of the syntax could be better. Nonetheless, C has proven to be an extremely effective and expressive language for a wide variety of programming applications. For the success of the C language, first, C language is available in almost all types of computers. C language is a computer language that is available both on microcomputers and on large computers or mainframe computers. Second, the C language code is portable and flexible. Applications written in C language for a particular computer can be used on other computers with only minor modifications. Third, C language only provides a few keywords. We already know that the ANSI standard C language only requires 32 keywords, Turbo only provides 39 keywords, C++ only provides 48 keywords. Let's compare it with other languages that do provide hundreds of keywords. The fewer keywords of a language uses, the easier it is for the user to learn and use the language. Fourth, C language program executable process is faster. Because the philosophy of the C language that only provides a few keywords, the consequence is that the program resulting from the compilation of the C language can be said to be relatively faster in processing compared to the results from other languages. Thus, applications made in C language will be efficient and competitive applications. Fifth, support a lot of libraries. It has already been mentioned that the readability of the C language is achieved by its library functions. The functions of this library are provided by the respective versions of the C language or can be processed from other sources. Thousands of C library functions have been available in the market until now, ranging from simple to complex library functions. For example, the library function to create indexes of database files using the B+tree used in DBase. This ample class and function library support allows the creation of macro applications. 6. C language is a structured language. C language has a good structure, so it is easy to understand. C is called a structured language because it uses functions as its part programs. A good C language structure is not only easy to learn, but also make programming easier, make it easier to track program errors, and will produce good program documentation. 7. C language is a middle-level language and is closer to machine language. 8. Program code is reusable, so it can be reused in other projects using only libraries and header files. 9. C++ can create high-quality graphics processor applications. Next, the deficiencies of the C language. First, the number of operators and the flexibility of writing programs sometimes confuse users. Second, for beginners, in general, it will be difficult to use pointers. So we can conclude there is nothing wrong with learning programming with this C language because it is quite organized and allows for large-scale or macro-scale creation. Next, Prospects in studying this language. There are academic positions such as masters, doctorates, postdocs, and assistant professors must of course be proficient in several programming languages, one of which is C language. Moreover, working in the field of computing is an avoidable obligation. In addition, the C language is also useful in finding jobs in the information technology field. Then the last one is business. Someone who masters programming languages will find it easy to start a business, especially a business that uses technology. Next, compilers for C language. Let's learn this concept of compilers with an example. Suppose you have been to a place where the languages you speak are completely different from each other, and now you had some traveling issues and want to communicate the same with them. How? Did you need a translator, right? You have to have someone who can understand your language and translate and let the opposite person understand what you wanted to say. In the same way, we will be writing our code in C programs and in a high-level language that is a human understandable format. How will the program understand what we have asked it to do? This is where the compiler comes into the picture. A compiler transforms and translates a high-end language to machine or low-level understandable language. The compiling process does basic translation mechanism and also error detection. The front-end compilation includes lexical, syntax, and semantic analysis, and at the back end, the compilation does the code generation and optimization. So there are many compilers in C. You know that the compilers for the programming language divided into offline compilers and online compilers. Then, for offline compilers for the C language, such as Birdland Turbo C, GCC, Portable C compiler, Clang, and Tiny C compiler. First, Birdland Turbo C. Turbo C is one of the basic and popular compilers for the C programming language. This was first introduced in 1987. It was popular for its small size, compilation speed, and low price. Once Turbo C++ got released in 1990, both the compilers are matched and the name Turbo C got discontinued. In 2006, Embarcadero Technologies had re-released Turbo C as freeware. Scout Tiny C compiler. The Tiny C compiler is designed to work on slow computers with little disk space. This is an ARM processor C compiler. This compiler started its support to Windows from 2005. Its file size is small, and according to the owner of this compiler, or Fabrice Bellard, the fastness of this compiler is around 9 times faster than GCC. The compilation, assembling, and linking of code were the main attributes considered for measuring the fastness of this compiler. This compiler had included many compiler-specific features to boost up the optional memory, bounded checker, and had greater code stability. This compiler allows automatic execution of programs during the compile time only using command line arguments. This way, programs are executed under Unix using shell scripts. The latest version was released on December 2017. Third, Portable C compiler. The Portable C compiler, or PCC, was a very early used and established compiler for the C programming language that is almost around mid-1970. This compiler had a long lifespan. This was prevalent during period in such a way that many of the C compilers were based on it. The advantages of PCC depended on its capabilities and probability predictions. PCC compiler was made such that source files were machine-dependent. Not all, but only a few of them. It can detect syntax errors and can perform perfect validity checks. A new version of PCC was released on 10 December 2014. Fourth, GCC. GNU Compiler Collection is the compiler produced by the GNU project. This supports many programming languages and it is a free software foundation under the general public license. This compiler was first released in 1987 and it supported only C programming language during the start. Slowly it expanded to C++, Java, Android, and iOS. Here, each of the different language compilers has its own program that reads the code written and sends the machine code as the output. All of these have a common internal structure. When a high-level language is written, as per the language it is written, the compiler parses the code in the language and produces an abstract syntax tree. GCC uses LALR parsers, but slowly switched to recursive descent parsers for C in 2006. Coming to the optimization part, as already known, this can occur during any pass of the compilation. However, here the bulk optimizations are performed before the code generation and after the syntax semantic analysis. Below are a few of the optimizations performed by GCC. It can eliminate the dead code pieces. It can eliminate the redundancy at the code level, replacement of aggregates with respect to the scalar level, can perform optimizations with arrays. In GCC backend is specified by preprocessor macros and functions specific to a particular architecture. This code is generally built by first calling a small snippet code which is associated with each pattern and generate instructions from the instruction set. It is done using registers, offsets, and addresses that are chosen during the reload pass. The current version of GCC is 9.2, which was released on August 12, 2019. Fifth, Clang. Clang including C is also a compiler for C++, Objective-C, and Objective-C++ programming languages. This compiler uses LLVM for the back-end code-related compilations. This compiler has been designed to act as a replacement for the GCC by supporting many of its compilation packs and language extensions. Clang has many contributors including Apple, Microsoft, Google, Sony, and Intel. It is open source software. LLVM was first used by GCC for the front-end compilation, but GCC had caused some problems for developers at Apple, as the source code is large and difficult to use. So, they had come up with Clang. One of the major goals for Clang is to provide library-based architecture. It's designed to keep more information during the compilation process than GCC. This also helps to preserve the overall shape of the original code. The error report generated by Clang during compilation is always in a detailed and specific in a machine-readable format. Clang had always aimed to reduce the over-usage of memory space and increase the compilation speed as compared with GCC, and due to these qualities, it had become one of the fastest growing used compilers during a point of time. But after a period, the performance of Clang started to come down. The reports told the performance had lagged, with almost large differences as compared with GCC, and started to have slower performance. The most recent comparisons indicate that both the compilers had come up and increased their performance and once again creating great competition between them. Yet, GCC remains to the top of the list. Next, online compiler for DC language. Online compilers are very easy to fire up and use with a web browser and an active internet connection, and that's all. Compile, save your code, and access it from anywhere without any overhead of management and resource limitation. These web-based applications can be used remotely through any network connection or devices or platform independent. The errors or output of the compiled program can be stored more conveniently. Though there are lots of online compilers available in the market, so it will be challenging to choose the best one, but don't worry, here is a list of top 5 free online compilers. You should try this at once. First, Geeks IDE. Geeks4Geeks is the most popular computer science portal with numerous awesome articles, and one of the best websites for learning and practicing code. It also has a smart IDE where you can run your code at lightning speed with your custom inputs. It has some great features. Write or paste your code of any popular programming language in the text area and easily run your code online. You can also download and generate URL of your code for easy sharing. Scout ID1. It is a free online compiler and debugger, specifically designed for programmers and developers, where you can compile and run your code with your custom input in just a matter of seconds. You can compile any programming language with ID1. It also has some awesome features like you can make your code secret to share with specific coders, and it's the best platform to share your code with your project members. Third, REPL. REPL.it is an online IDE that allows users to write code and build apps and websites using a browser and allows users to share projects in various ways. They also host many coding contests with exciting prizes. It has a premium tier called the Hacker Plan, which allows for more storage space, private code, and unlimited collaborators on a project, but you can also access this free of cost for 3 months with a GitHub education plan. Fourth, OnlineGDB. It is an online compiler and debugger tool for the most popular programming languages like C, C++, Python, Java, PHP, Ruby, Perl, etc. It is a very powerful compiler which is super fast, hints loads, and gives results instantly. You can also execute web development language including HTML, CSS, JavaScript, and SQL using this online code editor. Fifth, GDoodle. It is a free online compiler and code editor to save, run, and share code anytime and anywhere with no setups and hardware sources, but just an active internet connection and a web browser. Select any one of your preferred programming languages, write code, and evaluate the result of your code. No offense, but the offline compilers are very boring to use, and if you are a beginner, then setting up an offline programming environment in your computer system can be a headache. Better you can use these awesome free online IDEs and start coding. Nowadays, there are many commercial options available, but according to your need. These free compilers are just more than enough for practicing code. Next, code editor for the C language. First, Visual Studio Code. It is an open source code editor developed by Microsoft for Windows, Linux, and Mac OS. Visual Studio Code is based on an Electron framework. According to a survey done in 2018 by Stack Overflow, it was ranked the most popular developer environment tool among others. Furthermore, this IDE is also customizable, which lets programmers change the theme, keyword shortcuts, and preferences. Scout Eclipse. It is one of the most popular, powerful, and useful IDEs used by developers for C or C++ programming. It is an open source software which is simple and easy to use. Originally, it was used for Java programming, but now it is used for various languages. Eclipse can run Windows, Linux, and Mac OS. You can even file a book on their website if you encounter any on the Eclipse IDE or compiler. Third, NetBeans. It is one of the most used IDEs and can run on Windows, Linux, Mac OS X, and Solaris. It is a free and open source IDE that is written in Java. This IDE consists of an interface that comes with a drag and drop feature and a list of convenient project templates. You can use NetBeans to create C or C++ applications with dynamic and static libraries. It allows programmers to create C or C++ applications from existing code. Additionally, it provides a great set of tools for C or C++ programmers. NetBeans has numerous plugins that can extend the software. Developers can also remotely monitor their project's development. Fourth, Sublime Text. It is a cross-platform source code editor which supports several languages and markup languages. Sublime Text has a Python application programming interface and has a sleek user interface along with incredible features and amazing performance. Programmers can also add additional functions with numerous plugins that are community built. Fifth, it is one of the highly configurable text editors which is free for personal and commercial developments. It was designed and developed by GitHub and has a very large community. A multitude of plugins are available for this editor, which extends its features and makes it more customizable. It also supports OS X, Windows and Linux, and has a very simple interface to work on. Next, visualizing software for DesignOS. First, Gnome-Plot. Gnome-Plot is a portable command line-driven graphing utility for Linux OS Pro 2, MS, Windows, OS X, VMS, and many other platforms. The source code is copyrighted but freely distributed. It was originally created to allow scientists and students to visualize mathematical functions and data interactively, but has grown to support many non-interactive uses such as web scripting. It is also used as a plotting engine by the third-party applications like Octave. GNU-Plot has been supported and under active development since 1986. Second, Tableau. Tableau is a data visualization tool that can be used by data analysts, scientists, statisticians, and etc. to visualize the data and get a clear opinion based on the data analysis. Tableau is very famous as it can take in data and produce the required data visualization output in a very short time. And it can do this while providing the highest level of security with a guarantee to handle security issues as soon as they arise or are found by users. Tableau also allows its users to prepare, clean, and format the data and then create data visualizations to obtain actionable insights that can be shared with other users. Tableau is available for the individual data analysis or at scale for business teams and organizations. It provides a 14-day trial followed by the paid version. Third, Looker. Looker is a local data visualization tool that can go in-depth in the data and analyze it to obtain useful insights. It provides real-time dashboards of the data for more in-depth analysis so that businesses can make instant decisions based on the data visualizations obtained. Looker also provides connections with Redshift, Snowflake, BigQuery, as well as more than 50 SQL-supported dialects so you can connect to multiple databases without any issues. Local data visualizations can be shared with anyone using any particular tool. Also, you can export these files in any format immediately. It also provides customer support wherein you can ask any question and it shall be answered. A price quote can be obtained by submitting a form. Fourth, Zoho Analytics. Zoho Analytics is a business intelligence and data analytics software that can help you create wonderful-looking data visualizations based on your data in a few minutes. You can obtain data from multiple sources and mesh it together to create multidimensional data visualizations that allow you to view your business data across departments. In case you have any questions, you can use Zia, which is a smart assistant created using artificial intelligence, machine learning, and natural language processing. Zoho Analytics allows you to share or publish your reports with your colleagues and add comments or engage in conversations as required. You can export Zoho Analytics files in any format such as spreadsheet, MS Word, Excel, PPT, PDF, etc. The pricing options available for this software include a basic plan with a $34.1 per month billed yearly. It is in US dollar. Fifth, Sisense. Sisense is a business intelligence-based data visualization system, and it provides various tools that allow data analysts to simplify complex data and obtain insights for the organization and outsiders. Sisense believes that eventually, every company will be a data-driven company and every product will be related to data in some way. Therefore, it tries its best to provide various data analytics tools to business teams and data analytics so that they can help make their companies the data-driven companies of the future. It is very easy to set up and learn Sisense. It can be easily installed within a minute, and data analysts can get their work done and obtain results instantly. Sisense also allows its user to export their files in multiple formats such as PPT, Excel, MS Word, PDF, etc. Sisense also provides full-time customer support services whenever users face any issues. A price quote can be obtained by submitting a form. Okay guys, that's all from me. Thank you very much for watching this video, and hopefully this video is useful, and see you in the next video.